There are four general factors that influence the rate of a chemical reaction: temperature of the reactants, the concentration of the reactants, surface area of the reactants, and a catalyst, if applicable to the reaction. We'll first look at temperature. The following animation illustrates how temperature influences the rate of a chemical reaction. In general, if temperature is increased, the rate of a reaction will increase. Next, we'll look at how the concentrations of the reactants influence the rate of a chemical reaction. The higher the concentration of the reactants, the higher the rate of the reaction. This is because there are more collisions of reactants occurring in a unit time. Next, we'll consider surface area. Increasing the surface area of reactants will increase the rate of reaction. Increasing the surface area of reactants applies to solids and liquids. This illustration shows how the total surface area of a cube can be increased if the cube is diced into eighths. An analogy to this would be a log of wood being split into many, many smaller pieces. And finally, we'll look at a catalyst. A catalyst helps increase the rate of reaction by offering the reaction a different pathway. This different pathway has a lower activation energy than the original pathway. Therefore, lower activation energy increases the reaction rate. Under normal conditions, hydrogen peroxide decomposes into water and oxygen at an extremely low rate. But a catalyst, manganese 4 oxide, can be added to rapidly increase the decomposition of hydrogen peroxide. Here we see gaseous oxygen being evolved rapidly and an enormous amount of heat being released from the reaction. Here's an atomic level illustration of a platinum catalyst in automobiles. The catalyst facilitates the decomposition of nitrogen monoxide rapidly. As the nitrogen monoxide molecules contact the surface of the catalyst, the covalent bond between the nitrogen and oxygen is broken, and the two atoms rejoin with their own type to form oxygen and nitrogen gas.